Here we're given f of x equals the square root of the quantity 7x plus 1. For part A, we're asked to determine the value of f inverse of 6 without finding f inverse of x. And then for part B, we're asked to determine the value of the derivative of f inverse at x equals 6. Let's first review our notes. If f of a equals b, and f of x is differentiable at the point a comma b, and f prime of a doesn't equal 0, then f inverse of b equals a, and f inverse of x is differentiable at the point b comma a, and the derivative of f inverse at x equals b equals 1 over f prime of f inverse of b, which also equals 1 over f prime of a, because f inverse of b equals a. To answer the first part of this question, we'll use the fact that if f of a equals b, then f inverse of b equals a, which means if we can find an x value so that f of x equals 6, we can determine the value of f inverse of 6. Let's actually make a table of values where the first column is x and the second column is f of x. To get started, let's set x equals 0. If x equals 0, notice how f of 0 would just be equal to the square root of 1, which equals 1. So because f of 0 equals 1, this tells us that f inverse of 1 must equal 0. Again, if f contains the point 0, 1, the inverse contains the point 1, 0. But again, our goal is to find f inverse of 6. So we're looking for an x value where f of x would be equal to 6. We know the square root of 36 is equal to 6, so notice how if x equals 5, we'd have the square root of the quantity 7 times 5 plus 1, which would give us the square root of 36, which equals 6. So let's let x equal 5. So again, f of 5 would be equal to the square root of 7 times 5 plus 1 is 36, which equals 6. So because f of 5 is equal to 6, we now know f inverse of 6 must equal 5, which is the answer to part A. So for part A, let's say since f of 5 equals 6, f inverse of 6 equals 5. And now for part B, to find the value of the derivative of f inverse at x equals 6, we use the formula here. So the derivative of f inverse at x equals 6 is equal to 1 over f prime of f inverse of 6, which is also equal to just 1 over f prime of, we now know f inverse of 6 equals 5, which means the derivative of f inverse at x equals 6 equals the reciprocal of f prime of 5. Before we find this value, let's look at this graphically. So first off, the original function is graphed here in red. The line y equals x is graphed in black. So to get the graph of the inverse function, we can reflect the red function across y equals x, which gives us this purple function. So the red function is f of x, and the purple function is f inverse of x. In part A, we were asked to find the value of f inverse of 6 given by this point, but to determine the inverse function value, we actually found this point in the original function because the point 5, 6 represents the function value f of 5 equals 6. So because we found f of 5 is equal to 6, we knew that f inverse of 6 was equal to 5, which again graphically gave us this point on the inverse function. And now for part B, we're asked to find the value of the derivative of f inverse at x equals 6, which would be the slope of the tangent line to the inverse function at this point here. And to find the slope of this tangent line, we actually find the slope of the tangent line to the original function at x equals 5, and then find the reciprocal of that slope. The slope of the tangent line to the inverse function at this point is equal to the reciprocal of the slope of the tangent line to the original function at this point. So going back to our work, for our next step we need to find f prime of x. Let's write f of x using a rational exponent. So f of x equals the quantity 7x plus 1 raised to the 1/2, which means f prime of x is going to be equal to 1/2 times the quantity 7x plus 1 raised to the power of 1/2 minus 1, that's negative 1/2, times the derivative of 7x plus 1, which is equal to 7. So let's write f prime of x as 7 all over 2, and let's write this as the square root of the quantity 7x plus 1. Notice how we had a negative exponent here. If you move it down to the denominator, it becomes positive 1/2, which is the same as the square root. And now we need to find the value of this derivative function at x equals 5. So f prime of 5 is equal to 7 over 2 times the square root of, this is going to be the square root of 36. So we have 7 over 2 times 6 is equal to 12. So the derivative of f inverse at x equals 6 is equal to 1 over 7/12. Well, 1 over 7/12 or 1 divided by 7/12 is equal to 12/7. So for part B, the derivative of f inverse at x equals 6 equals 12/7. So going back to our graph one last time, we just determined the slope of the tangent line to the inverse function at the point 6, 5 is equal to 12/7, which is equal to the reciprocal of the slope of the tangent line to the original function at the point 5, 6, which we found was equal to 7/12. I hope you found this helpful.